In this video, we are going to go over a basic intro of significant figures, kind of what they are and how to tell if a number is actually significant. Okay, sig figs. That's the abbreviated form of significant figures. Sometimes someone will call them significant digits or sig digs, but they're terrible. We call them sig figs here, okay? So significant figures. What is a significant figure? It just tells us what numbers actually matter in the measurements that we have, okay? So it tells us which numbers are significant, aka which ones actually matter in your measurements, okay? I guess we should just go over the rules, all right? And then we can look at examples. So rule number 1.
All exact numbers are significant.
Okay, all exact numbers are significant. So that makes it really easy. If you're talking about like 1 dozen, the 1 and the 2 are significant, okay? So okay, let's break it down. Right? A dozen is 12. And a dozen is an exact number. So the 1 is a significant figure and the 2 is a significant figure. They are both significant figures. I have 2 sig figs in this number. Okay? If I had a $100 bill, which I definitely don't. All right, but if I had a $100 bill, I have exactly $100, right? I don't have like $100.2. I have exactly $100. Boom, all right? It's exact. The 1 is a significant figure. The 0 is a significant, and the other 0 is a significant figure. I have 3 sig figs in that exact number, okay? So whatever your value is, if it's exact, every single digit in the exact number is significant, okay? That's the easy one, all right? The rules get harder when you have inexact numbers, okay? So when you're talking about inexact numbers, all right? Then we get into our next rules, okay?
All non-zero numbers are significant.
Okay, every single non-zero number. So if I had 1776, okay, and I was trying to count up how many significant figures I have in 1776. Well, they're all non-zero numbers, so I have 1, 2, 3, 4 sig figs, right? Each digit is significant. Each figure is significant. Okay. You can even do a decimal. Let's make sure we look at this, right? 8.12465. Whatever. Okay, random. It doesn't matter. They're all non-zero numbers, so they're all significant. The 8, the 1, the 2, the 4, etc. So I have 1, 2, 3, 4, 5, 6 sig figs. All right? So rule number 1 and rule number 2 are easy-ish. Then we get to rule number 3.
Zeros are sometimes significant.
Okay, so we break them up. All right, we break up our zeros. We have leading zeros. We have, I like to call them trapped zeros, and we have trailing zeros. Okay, it's the 3 different types of zeros. So a leading zero would be like a decimal number. Okay, 0.0008. Okay, a trapped zero, I think they call them confined zeros, okay? If you want the, the way that your book will talk about it. But I like to think about it as trapped, okay? They're trapped between 2 significant numbers. So if I had 507 of something, okay? That 0 is trapped between 2 significant figures. A trailing 0 would be zeros like 100, right? Trailing there at the end. Okay? So another way to think about it, leading zeros, L leading, those are the zeros that are on the left. Okay? And any zeros that are on the left are not significant. No. Okay? To the left, sorry, Beyonce. All right? So any zeros to the left, not significant, which means in this example, 0.0008, I only have one sig fig. All right? If I had a different example, 0.0123, okay? If I had these zeros, any zero to the left, not significant, I have 1, 2, 3 sig figs. All right? There we go. Trapped zeros. This is a big yes. Okay, they're always significant. All right, so if the zero is trapped between two significant numbers, it's always significant. So in this case, I have 1, 2, 3 sig figs. All right. You get it. I don't think I need to give you another example, but just in case. Ooh, let's do 0.01205. Okay, if I had a number like this, my leading zeros, my zeros to the left, don't matter. My zero in the middle, that's trapped, does. So in this case, I have 1, 2, 3, 4 sig figs. Then if I have trailing zeros, okay, trailing zeros are again a sometimes. All right, trailing zeros are sometimes significant. So this breaks up if you have a decimal versus if you have no decimal. All right, having to abbreviate there because I'm running out of space. So if I have a decimal, we'll just look at 100. If I went 100 with a decimal point versus if I had 100 without a decimal point. Okay, you'd think it's the same number, right? But it's not. That decimal, it changes stuff, okay? So if I do have a decimal, then yes, those trailing zeros are significant. The decimal tells me I know exactly what those things are. Okay, these are significant. If I don't have a decimal, then no, they are not significant. All right, because I'm saying there's no like full stop, I need these numbers, okay? So in this case, 100 with a decimal, I would have 1, 2, 3 sig figs. In this case, without a decimal, I only have 1 sig fig, just that number 1, okay? All right, so here are 4 examples. And what I want you to do is try and count up how many significant figures are in each number. Okay, so pause the video right now and try it on your own to make sure you get it correct. Okay, this one is the most complex, so I'll save it for last. All right, this guy, 500, there's no decimal point. These are trailing zeros, so not significant. There's only 1 sig fig, okay? In this, leading zeros to the left don't matter, so there's only the 8 and the 2, so 2 sig figs, all right? In this case, there is a decimal, so any zeros to the right with a decimal are significant, so I have 1, 2, 3, 4, 5 sig figs, okay? And in this case, leading zeros don't matter, trapped zeros do, and trailing zeros when I have a decimal also matter. So this will have 1, 2, 3, 4, 5, 6, 7 sig figs, all right? Okay, hopefully that helps. You do have to understand sig figs because we do a lot of calculations with sig figs, and that's what's coming next. You're just gonna love it.